Alrighty, welcome back for homework for 713. So number 29 here says for each scatter plot below, determine if there is an association between the points. Label each graph as showing positive association, negative, or no association. If there is no association, write a sentence describing, or if there is association, write a sentence describing it. Okay, so for this first one, we're looking at the grade point average and then average number of hours of TV that you were watched per day. So we can definitely see that there is like a general path, right? It's not like a straight line, but there is some sort of association here of it trending downwards. So we can say that this is negative association because it's kind of coming down, right? Sliding down. So negative association. And then we can write a sentence, right, to describe it. So we can say as the number of hours watching TV, and I'm just going to use like increases, goes up, the GPA, right, the grade point average, tends to go down. Okay, and that's all we really need is just something short. Okay, now on this one, we have the number of gray hairs on one's head and the age, and we can kind of see that there is some sort of association, right? The points are generally trending up. So we call that positive association. And then we can say, as age increases, the number of gray hairs also increases. It's a little up arrow. Okay. All right, how about the length of one's hair compared to their shoe size? These dots are all over. There's not a general trend going up or down or across or up this way. So we would say no association. And we would say just between the length, like there's no association between length of hair and shoe size. Right, because I mean, you could have long hair, you could have big feet, you could have long hair and have short feet. It doesn't order either way, vice versa. So, all right, for the next one, it says that we are making a graph of Team 2's data from problem 25, which we did in class. So I'll kind of help you through. We kind of gave you this information here that you'll need. So it says that we need to draw a straight line that models the trend of the data in the graph. Remember that the line does not need to intersect each of the points. All right, so first of all, we need to graph our points. So to do that, I'm just going to use a pen here just to make my axes. So we don't need any negative data, so we're just going to make this quadrant with the positive data here. Okay. And I'm going to put the height, right, this height right here on the y-axis. Okay, so it looks like we're going from 0 up to 24. So I could just, maybe I'll just go by 2. Like I'm going to go 2 and then skip a line. Okay, so 2, 4, 6, 8, 10, 12, 14, 16, oops, wait, skip one, 18, 20, 22, oh, and 24, way at the top. Okay, perfect. And then at the bottom, I'm going to do the same thing. So 2, 4, 6. I'm just skipping a line every other time. So really, I'm going by ones, but 14, 16, 18, 20, 24. Okay, that should be enough. Okay, now we can plot our points. So over 3 for the first one here, and then up to 24 way at the top. Woo! Okay, don't lose my line. Don't lose my line. There it is. Okay. Next up, 621. Whew, man, these lines are tiny. Okay. I have to like stop partway so that I don't lose it. And then 20, 21. 9, 18. 9 is in between these two. Let's see, here's 14. Almost there. There we go. And then 12, 12. Okay. At least they're getting closer. There's 1. 15, 6 is going to be 15. There's 6. And then 18, 0. Whew, that one gets to stay around the line. Okay. So then we are drawing a line, right, that's going to model the trend line. If I were you, I would find something, whoopsies, I would find something that's like you can draw a line with. I just happen to have this Gorilla Glue, so I'm going to be drawing it with Gorilla Glue packaging. All right, so we're, again, not trying to connect the lines. We're just trying to get it to go through most of them or split the lines in half about. Okay, so there's my line. Thank you, Gorilla Glue packaging. All right, there we go. And that's just our trend line. Okay, see how I have some line, I have some points over here, I have some points here, I have some on my line. That's all we're really looking for. Okay, so then for part B, it says that we need to use our line of best fit to predict the height of the plant when the seed is 14 centimeters deep. Okay, so that's the depth is down here. So at 14 centimeters, I'm just going to kind of come up and generally use my line to tell me about where am I. I'm about here. So I'm going to come on over. It looks like I'm, for my graph, I'm about a 9. It could be like 7, 8, 9, somewhere in there. So I'm going to say about 7 to 9 centimeters, right, deep. Okay. Then I think there is a part C, but it might have gotten, yeah. Okay, sorry guys, it got chopped off. So I'm going to just read it and then come back to it. So my graph, what is the y-intercept and predict the y-intercept in this situation? Okay, so if we look at our graph, we're trying to say about where is this going to hit my y-axis, and I can't see that on my graph, so I kind of am going to use my pen here to kind of show you where about that might be, right? Meaning if I were to extend this and extend this line, I'm hitting it about here, which when I look at my like tick marks, it's pretty close to about 30 probably for where those are going to intersect, right, for the y-axis. So on this side, I'm just going to be writing, I guess I'll write this part in pen, won't mess up here, about 30 centimeters, right, if the seed is left on the surface. Then the plant will be about 31-ish, 30 centimeters. Just use your estimate, okay? I'm going to switch on back to pencil here just because we all know sometimes I mess up and I have to erase. Okay, number 31. During a given week, the museum had attendance as shown at the table at the right. So this. Numerically, we want to summarize the center and spread of the attendance by finding the median and the interquartile ranges. So to do that, remember, you're going to put your numbers in order. You're going to find that average. So for our median, right, like the middle, that's the 731. Because when I put these in order, right, and I like move in, this was my middle number. Okay. Then my interquartile range, and I actually had to look this part up because I don't honestly remember it. I don't use it all that often. I take my 870, right, from over here, which was my first quartile, and I subtract it from my 593, which was my third quartile, and I get my 277. Okay. All right. Then the museum management needs to tell the staff members their work schedules a week in advance. The museum wants to have about 1 staff member for every 150 visitors. How many staff members should be scheduled to work each week? Okay, so there we can set up a proportion for this problem, right? And we can say that they should have 6 employees who would handle about like 750 to 900 probably visitors. So what that means is, like, because they're saying for every one, they would have one staff for every 150, and that's per day. So then when we think about for a week, right, how many people that would be, that's a lot more. And then we can put our X here, multiplying that by our 7, and then that would give us, then we can kind of set up that proportion and figure out about how many. Okay, so then for C, why is a scatter plot not appropriate for this data? Well, it doesn't really have like good distribution of the data. Like we wouldn't be able to see it all. So we could say that it's interested in distribution of attendance. Of attendance, not in like the day, per day. What could they use? Maybe like a box plot might work better. It's just the numbers don't go in that type of order, so it wouldn't really help us to do a scatter plot. All right. Next up, for 32, we are simplifying each expression. These are pretty simple. You can just plug these right into your calculator. That's basically what I would suggest because we're just multiplying, remember, for these two. So when I plug that in, let's see, I'm getting 16 over 30, which I know can be simplified to 8 over 15, right? When I multiply this and simplify, let's see, I'm getting 4/7. Again, I'm multiplying across. I'm getting negative, well, 20. That can be simplified to 10 21st, 20 over 1. Okay, negative 10 over 21. And then flipping that over. Ooh, now we have a mixed number. All right. So remember, we have to convert this to a fraction greater than 1 first by multiplying the denominator. So that would be negative 3 plus 1 would be negative 2/3. So then we can go ahead and multiply these two, and that would give me negative times negative is positive, so 16/15. Right, when we multiply our 4 times our 2, our 5 times our 3, which can also be written as a mixed number of 1 and 1/15 if we wanted to keep it as a mixed number. All right, then it says that we need to solve each equation below 4x, and then we need to check our solution. Okay, so solving for x. Remembering that we need to do our distributing here probably first before we do anything else. So negative 2 times 4 is negative 8. Negative 2 times positive 2 is negative 2x. And then these guys we can just rewrite as well. Okay, so a couple different ways that I can do this, and I can also view this just so that we know. I could just view this like this as well. Okay, remembering that I can combine my like terms, I can convert these to decimals. I mean, there's a lot of different ways that I can help myself here. So I'm going to start by combining my like terms and converting into decimals. So I can combine these two guys, right? This is a negative 2x. So when I combine that with my 3/4, that's going to leave me with negative 1.25. Oops, I did not give myself very much room. X. I'm just going to add my negative 8 over here on this side because I kind of ran out of space. And then negative 0.5x plus 0.25, right? Converting it to a decimal. And then let's see. Let's go ahead and add my 0.5x on both sides. Okay, so that leaves me with negative 8. And then subtracting that would be negative 0.05x. 0.25 left over here. I can add 8 on either side. Okay, so moving it up over here, I have negative 0.75x equals 8.25. I know that they're decimals, but they're not that scary. And I mean, I can do that, right? We can do those. So dividing by that number in front, We could have also we could have busted them with some fraction buster also, but I don't know. All right, then when I go ahead and divide this, I actually come out with a nice number of -3. It kind of works out well in the end. Okay. When I had to simplify it as well. Okay, for my next one, I could combine like terms, or I could simplify it. How do I want to do it? All right, so I can combine my x's, right? Negative 5/3 and -1/3 is going to be -6/3, which when we combine is actually nice because this equals -2, right? So really, that means that I have -2x plus 2/5. Oh, 1 and 2/5. Remember that guy too. So 1 and 2/5 equals 0. If I wanted to convert this into a fraction, right, I certainly could. I could say that it would be 7/5, if that's easier to see. We can also see it like that. And then I can just solve for x. So subtract 7/5 on both sides. Leaves me with -2x equals -7/5. I can divide by -2, right? And I'm just going to leave it as my negative, or as my 7, because negative divided by negative is a positive, as my 7/10. Because that's not going to be a nice decimal, so we're just going to leave him like that. All right. Then for our last one, we have the figures at the right are similar. Describe a sequence of transformations that will exhibit the similarity between them. So we have to transform this kite over to here. Okay, so we're moving this over here. So you can kind of see what I was doing with my fingers, right? I can use a translation, so I could slide it over, and then I could rotate it, right? And I could dilate it then to make it the same. Okay, so we're going to say translation, or translation. Remember, that's like a slide. And then a rotation. Since they didn't give us like a point, we don't have to describe, like it would be a 90-degree, technically that would be 90 degrees clockwise, right? But we don't have a point of rotation, so we can just say rotate. And then we might have to do a little bit of dilation to get it to match up. All right, that's really all we need from that one. Well, thank you very much for watching. That is homework for today. Come on back tomorrow.